Okay, let's go ahead and solve for the voltage gain V out over V in of this common gate amplifier. And the reason it's called a common gate amplifier is because the gate terminal of this NMOS is connected or common to ground. And essentially, I've drawn out the small signal circuit, and let's go ahead and write different KVLs and KCLs to see if we can find V out over V in. And the first thing I'm going to do is write a KVL here and say that plus VGS plus Vin has to equate to 0. So that means that VGS is equated to minus Vin. So that means that this voltage generated current source here can go to minus GM Vn. If I go ahead and place a current coming out of my V out here, call this I out, I can then say that V out using Ohm's law is equated to minus I out times RD. So then this is equated to minus parentheses I out going in this direction is going to be this current source. So minus GM Vn plus the current source going through this channel length modulation resistor RO. And in order to find this current, I can say that this is V out and this here is Vn. So I can say V out minus Vn over RO is that current times RD. So then let me go ahead and pull things out. I can then say that V out times 1 plus RD over RO, which is this term here, is equated to Vn times minus GM RD. Actually, this is going to be a plus, and then plus RD over RO, which is this term here. So then I get my AV is equals to V out over Vn, which is equals to GM RD plus RD over RO over 1 plus RD over RO. If I go ahead and multiply my numerator, my denominator by RO, I'm simply going to get GM RO plus 1. I'm going to pull out an RD here, divided by, this is simply going to be RO plus RD. And this is your final solution. If you like this type of content, please check out my YouTube channel at Professor Gavala. Thank you.